Okay, so let's talk again a little bit more detail about how the servo motion module actually works. So to actually do that, I'm going to start off with a brand new sketch. And just like I have in the past, I'm going to go ahead and put the module in here. And for me, I can get it from the last file that I had that I used it, or I can still just get it from downloads. So I'm going to go ahead and grab it here from downloads, open it up. And then, lo and behold, it appears here on a tab. And then, just as I've done in the past, I'm going to take this stuff here, that the globals and the setup, and I'm going to copy it. And I'm going to go to my main page. I'm going to replace the setup. And boom, now I have the code already ready to go. In fact, if I just go ahead and load this, I'll save it by the default in this directory here. Hit save. Okay, you'll see that the first thing it's going to do is it's just going to light this light up and it's going to flash it. Okay, so we're ready to go. There's nothing in the loop. There's not going to be any action. It's just loaded and it's good to go. It's good to do something with. So let's look at the module itself. Okay, it's laid out in a really logical pattern. The increased complexity is at the top of it. And then the simplest, lowest level functions are down here at the bottom. And its lowest level function is going to be this creation of the pulse, the create pulse function with a couple of arguments in it. And just like I talked about in the last video, you know, we have to be able to create a pulse to be able to drive that servo. And that pulse has between 1 and 2 milliseconds. So if we look at the code, what's actually happening here is the servo pin is being handed down in the first argument, and the pulse width, that 1 to 2 milliseconds, or 1,000 to 2,000 microseconds, is being handed down in the second argument. And that is just simply going to be telling it which pin to make high, and then for how long it's high, then it goes off. So it's a simple little function. It just creates a pulse. So one level up from that is, so this would be just one wheel, by the way. So this would be one servo, one pulse train, okay? Not even a train, just one pulse. So we go up here, and what's going to be, the functions here are going to be to set 2 pulses, okay? So it's going to send out 2 pulses, one to the left servo, one to the right servo, and then that 20 millisecond delay, okay? So in this function, for example, this right step slow, what it's going to do is it's going to do a single pulse on 2 motors and then wait 20 milliseconds. And that's all it does. All right? So if we go up one more level, now we get into, you know, a pulse train. So this is what's going to send the pulses in a train so that we get a certain number of steps. So for example, this forward fast with the integer x, so if that's 100, so that 100 is going to get put into this for loop, which means it's going to pulse, or it's going to call upon the forward step fast function 100 times. And if we go down here, the forward step fast is actually going to create a pulse, another pulse. In other words, it's going to create a single pulse to the left servo, and then a single pulse to the right servo, and then wait 20 milliseconds, and those pulses are controlled by this function. Okay? So when you put it all together, you end up with these really nice pulse trains of a specific pulse duration. Now those pulse durations that we see called upon, so for example, you know, here, the left forward fast and the right forward fast, those are declared as globals. Well, they're actually declared as constants here. So for example, here's my left forward fast and my right forward fast. And of course, those are opposite numbers. They're one's 2,000, one's 1,000, because if my thumbs were the hubs of the servo, all right, it's not 2 servos sitting on top of each other, both spinning in a clockwise position. It's actually 2 servos that are kind of mirrored. So therefore, one of them has to, for the robot to go forward, one has to spin clockwise, while the other one spins counterclockwise, because they're mirrored of each other. So that explains why forward fast with the left servo is a 2,000, and forward fast with the right servo is a 1,000. Okay? Likewise, if I want to go reverse, it's 1,000 and 2,000. But of course, it doesn't affect stop. They're both going to be 1,500. Okay? Because that's what causes the motor to stop. So if I were to take and there's actually a demo code right here. I'm going to go ahead and run it, and you can see what happens. It's going to be a forward, it's going to be a stop, it's going to be a left, it's going to be a stop, forward. It's a series of calls to these functions down here, which of course call the functions down below. And if I put that in my main sketch, say here, and then I don't want it to run over and over again, because that would be kind of hard to see. Let's go ahead. Oh, did not mean to do that. Sorry about that. I actually meant to have it here. Let's put a while true or something to make it stop, because we don't want to have it run over and over and over again. So if I load this up like so, all right, and we see my robot, you can see lights flashing. If I turn it on, oh, look at me. See, I didn't plug the servo back in after the last demonstration. I apologize. Let me plug this servo back in. This is where I had in my last video a demonstration of the regular non-modified servo. So let me reload it. And we'll come back over here. And once it loads, the light will begin to flash. Turn on my motors. And we can see that it works out. In fact, I'll demonstrate this on the floor so you can actually see it. Let me unplug this. And let me pause this real quick, make sure my camera is set up. Alright, so let's set this guy up. Turn him on. Light flashes. After it gets done flashing, off it'll go. And we can see that it's doing the series of functions that were in the demo. Okay. So, let me show you one more thing, since I've only been a couple of minutes. And let me turn this camera. All right. So let's say, for example, we want our robot to go really very straight. Okay. All these motors have slight variance between them. They all do. They're never really perfect. Let me turn that off again. They're never perfect. And if I want my robot to go perfectly straight, I might have to do some minor adjustments to it. So that being said, we can do that manipulating these values here. Okay? So my 1,000 and 2,000. Now, I'm going to point out that this robot is currently set at 5 volts. Okay, so that means this entire side is going to be a regulated 5 volts, which is much easier to predict because as these batteries die until they reach a certain threshold, it's going to be a steady 5 volts to my motor. If I could put it on VN, which would then mean that I would be getting the full energy of the pack, but I'd also be seeing the full decay of the pack, and whatever I've done to make my robot go straight is simply going to start to veer as the batteries begin to die. Okay? So having it on 5 volts slows the whole thing down maybe a little bit, but it does make it more reproducible when I'm trying to get my robot to actually do a precision movement. Okay? So that being said, what I'm going to do is I'm going to take my code here, and instead of running motion fast test, I'm just going to run forward fast. Alright? So I'm going to take this, and I'm going to do a forward fast here. And I think I'll make it, oh, I don't know, 200, so we can kind of see it go for some distance. And I'll plug it in. And we will load up our code. And once it starts to flash, I'll know that it's loaded and it's safe for me to unplug. Okay, so give me one moment as I set up my other camera again, and we'll watch this guy go cruising down the floor. Alright, so we're going to take advantage of the orientation of the wood planks on my floor here. And you can see that I've got my robot. I'll move it over here. I've got my robot sitting between these two planks. Hopefully that's clear. And I'm going to line it up. And I'm going to try to get it perfectly straight and let it go. And we can see that my robot is veering off to the left. Okay? So it's veering off to the left. So if we were to take a look at that, all right, so my robot is veering in this direction. All right, well that means we have two choices. In theory, we could speed this wheel up, right? I could speed this wheel up, and that should probably straighten it up. Or I have to slow this one down. But let's remember, our robot is already going full throttle with both wheels. Okay? So I really don't have a practical way of speeding up left. It's already going at 2,000. So my only choice is slowing down the right. Okay? And I can do that by increasing this value, some number, and I'll try, I don't know, I'll try 200 here. Okay? Remember, 1,500 is a dead stop. So we want to get closer to 1,500 away from 2,000 to slow down the motor. So we'll just have to try it. And I'm not going to do this too many times. I'm not going to shoot for perfection, but we're going to give it a whirl. So I'm going to load this up. All right. And I'm going to switch to this camera. And let's go ahead and take it over there. Set it down. And wow, that's actually pretty darn good. I'm going to try it again. Get it straightened up. I'm pretty happy with that. I think the alignment is really quite good. I could probably tweak it ever so slightly more, but there's probably really no reason why you want to watch me zero it into a perfect alignment. But that gives you an idea. So you can actually tweak this guy and get it to go as straight as possible by making subtle adjustments to these numbers here. Keep in mind, the closer you get to 1,500, the more rapid it is. That was 200, and it made a subtle change. If I took it down another 200 to 1,400, well, it would be a pretty dramatic change, and you would see your robot just kind of moving off into an arc. So hopefully this was useful, and next time I see you, we'll probably try to make this guy do a more complex behavior. And I will see you all again soon.